In this video, we'll learn about potential bias that can be found when analyzing data. Bias in data occurs when a result is more favorable to a certain outcome. This can happen for a variety of reasons. There can be bias in the way the data is collected, the way it's analyzed, and the way it's shown in a visualization. Now, in this lesson, we'll mostly focus on bias in data collection, but we'll revisit this topic a few times in future lessons. Bias in data collection can happen if the information gathered does not accurately represent the population as a whole. Let's say you're running a survey at your school. If you only ask the first 20 people you see, your data might not reflect the whole diverse population of your school. What if those first 20 people you saw were all males or all 10th graders? It's important to have diversity in the population you survey. It's also very important to have diversity in the team who is conducting the data analysis as well. Let's talk about machine learning just a bit to understand bias further. Machine learning is a branch of artificial intelligence focused on building applications that learn from data. These programs can be trained using data and are able to learn and improve on their own. A very important factor in reducing bias deals with the selection of training data used to build these programs. If the program is trained using data sets that contain very few examples of one particular demographic group, it could be worse at accurately recognizing or learning about these members of that group. An example of a biased program due to underrepresentation in data was brought forward by Joy Buolamwini. Joy is a computer scientist and the founder of the Algorithmic Justice League, whose mission is to ensure that artificial intelligence is equitable and held accountable. Joy's motivation for founding this company started when she attempted to use a facial recognition program. The program would not recognize her face until she put on a white mask. Then the program worked. Not only are certain groups undersampled in data that trains these programs, but the same groups are less likely to be involved in the development of the programs as well. An emphasis needs to be placed on creating more diversity in tech companies by including more women and more people of color. Another well-known example is a biased data algorithm that was being used by Amazon as a recruitment tool. They discontinued using it after they discovered a gender bias. The data used in this case was taken from resumes that were submitted to Amazon over a 10-year period. However, most of these resumes were written by males. The algorithm used machine learning and was taught to recognize word patterns in the resumes, rather than looking at skills and experience. Because of this, any word or phrase that was associated with the male gender, like fraternity, or a connection to sports and certain activities, bumped a resume up the line. While any word associated with females, like sorority or the name of a woman's college, penalized the resume. Bias can be found in all aspects of the data science lifecycle. For now, within your projects, you'll want to focus on possible bias that can be found within a statistical question and in the data collection phase. Pause the video and read these 4 questions. All of them, except one, contains an element of bias. Can you figure out which question is the unbiased question? Did you get it? Now, this is the only question that doesn't lead towards one answer over the other. All of the other questions include words or phrases that show that one answer is favored over the other. You could even make an argument for choice C including some bias, since the question is forcing a choice of either daytime or evening television. Well, what if the person doesn't like either or doesn't watch TV? It's very hard to find a question that is completely unbiased. Many times it can be real hard to notice. Pause the video again. This time there is only one question that is biased. Can you find this one? The word mindless leads people to think that sitcoms is the incorrect choice. The person asking this question is biased towards watching news over sitcoms. Another type of bias to watch out for is confirmation bias and can occur in the data collection phase of statistical research. Confirmation bias is when you search for and use only data or information that agrees with or confirms what you think the answer or outcome should be. The vastness of the internet can be a tool, but also a crutch. You will always be able to find articles and data analysis that support both sides of an argument. A few strategies that can be used to avoid confirmation bias is to first and foremost, just be aware of your own bias. What are you hoping the study shows? You should also go into the study with the goal of using data to discover rather than to confirm. You may get through the whole study, make a few discoveries, but still not fully answer your hypothesis or question, and this is perfectly fine. You also want to be sure in intentionally searching for data or evidence that could possibly disprove your hypothesis. And lastly, ask a friend to review what you have and come up with some arguments to challenge your position. There are many ways that bias can creep into data analysis. If the data set is incomplete, this would cause the analysis to be inconclusive as well. Data sets that lack a diverse representation or context make ways for potential bias, no matter how good the analysis is. If the data is incomplete or bad, then the analysis is incomplete or bad. The data in a dataset can also be used incorrectly, like in the recruitment algorithm. The choice to use and analyze word phrases instead of skills and experience was a main part in the gender bias that followed. In short, it's important to know that the data that is missing may tell as important as a story as the data that is there. Another bias to consider is interpretation bias. This is similar to the bias found when posing a statistical question and can show up during the interpretation stage of the data science lifecycle. There's a famous study regarding interpretation bias. Elizabeth Loftus, a cognitive psychologist, carried out research where she showed a film of car crashes to participants. Then she split them into groups and separately asked them several questions about the car crashes. The questions were the same except for a simple change in the verbs used for each group. For example, one of the questions asked was about how fast were the cars going when they bumped. And the other group was asked about how fast were the cars going when they smashed. To her surprise, the choice of verb had a huge impact on their estimates. Those who were told they smashed guessed higher speeds, as compared to those who were told they bumped. This is important to remember when you're interpreting or presenting data. You'll want to be aware of what words you're using. A rule of thumb for avoiding bias is to make sure that you don't work in isolation as much as possible. Work with others when you can during all phases of the data science lifecycle. Check for and use multiple data sources to compare and verify instead of just referencing one data set. And reach out to others to review your results. All of these strategies will help limit bias from creeping into your study. All right, well now it's your turn to dive deeper and explore more about these concepts.